Imagine a clock with no hands, no numbers, no gears, and no electricity. Now imagine that it still works after sunset. More than 3,000 years ago, ancient Egyptian timekeepers could watch a shadow cross a stone, follow stars through the night, or measure water escaping from a bowl. From those simple clues, they built a system that still hides inside your phone, your school day, and every clock on Earth. But here is the first twist. The Egyptians did not invent time. They invented ways to organize it. And one of their most important ideas was so powerful that we still divide every day around it. Why 12? Long before anyone needed to know whether it was 8:17, people lived by repeating events. Light meant wake up. Darkness meant rest. The changing moon suggested months. The return of heat, rain, and harvest marked the year. In Egypt, one repeating event mattered more than almost anything else: the Nile flood. Its waters renewed farmland and helped determine when people planted and harvested. So Egyptian time was not first built around appointments. It was built around survival. Farmers needed to anticipate seasons. Priests needed to schedule rituals. Officials needed to record taxes, work, and royal events. A kingdom could not run on, sometime after sunrise. Nature supplied the cycles. Egypt turned those cycles into a shared system. That distinction is the key to this entire story. Time passed everywhere, but a calendar made everyone agree on where they were inside it. By at least the middle of Egypt's Old Kingdom, around 2450 BCE, the Egyptians were using a remarkably clean civil calendar. They divided the year into 12 months. Each month had 30 days. 12 times 30 gives 360. But the solar year is longer than that, so they added 5 extra days at the end. Those 5 days sat outside the ordinary months, almost like a small bonus season. The year was also grouped into 3 agricultural seasons. Akhet was the season of inundation when the Nile flooded. Peret was emergence when land and crops appeared. Shemu was harvest. That structure was easy to record, easy to repeat, and useful for running a large state. 12 months, 30 days each. 5 extra days. Total, 365. It sounds almost modern, but this beautifully simple calendar contained a hidden error. Earth does not travel around the sun in exactly 365 days. The true year is roughly a quarter day longer. The Egyptian civil calendar did not regularly add the leap day we use today, so it slipped by about 1 day every 4 years. At first, that difference would have felt tiny. But tiny errors accumulate. After 40 years, the calendar would be around 10 days away from the seasonal position where it began. Over centuries, its new year wandered through the natural seasons. This creates a wonderful contradiction. The calendar was orderly enough to manage a civilization, yet it slowly moved away from the sky and river that inspired it. The Egyptians also watched Sopdet, the star we call Sirius. Its first visible appearance before dawn was associated with the approach of the Nile flood and with the new year. The sky was not decoration, it was information. But measuring a year is one thing. Dividing a single day would require a stranger idea. The Egyptians separated daytime and nighttime into 12 parts each. Put them together, and you get the ancestor of our 24-hour day. During daylight, a shadow clock or sundial could track the sun's movement. As the sun crossed the sky, a shadow moved across marked sections. Simple, but there was a catch. Summer daylight lasts longer than winter daylight. If every daylight period is divided into 12 parts, then a summer hour becomes longer than a winter hour. Night hours changed too, so an ancient Egyptian hour was not necessarily a fixed 60 minutes. It was a seasonal slice of day or night. Think about that. In their system, the clock could stretch. The purpose was not to create perfectly equal seconds. The purpose was to identify a useful part of the daily cycle: an hour for work, an hour for ritual, an hour in the sun god's journey. Equal-length hours came later, and the Egyptians did not leave evidence that they counted our minutes in seconds. Still, one question remains. Shadows disappear at night, so how could they count 12 night hours in total darkness? The answer was written across the sky. Egyptian observers tracked groups of stars, now called decans. Different decans appeared or crossed certain positions as the night progressed. Their movement helped mark the passing night hours. Imagine lying beneath a clear desert sky. One star group rises. Later, another takes its place. To a trained observer, the sky behaves like a giant rotating dial. Some Egyptian coffins preserve star tables that scholars sometimes call diagonal star clocks. They helped connect particular star groups with portions of the night at different times of the year. This is not a wristwatch. Clouds could hide the stars. observations demanded knowledge, and seasonal changes complicated the pattern. But the idea is extraordinary. The entire night sky becomes a machine with no moving parts except the universe itself. Then came another problem. What if the stars were hidden? What if a temple ritual had to be timed indoors? For that, Egyptian timekeepers made darkness visible with water. Picture a stone or pottery vessel filled with water. Near its base is a tiny opening. Water escapes at a controlled rate. As the level falls past markings inside the container, an observer can estimate how much of the night has passed. This is a water clock, often called a clepsydra. It has no hand sweeping around a dial. The falling waterline is the hand. Evidence for Egyptian sundials, shadow clocks, and water clocks appears by the New Kingdom, beginning around 1500 BCE. Surviving examples show how physical objects could turn an invisible passage into something people could see. The water clock solved something a sundial could not. It worked without direct sunlight, but it was not magically precise. Flow changes with water pressure, the size of the opening, temperature, and the shape of the vessel. And because Egyptian hours changed with the seasons, timekeepers needed markings suited to different parts of the year. The machine was simple. The thinking behind it was not. Now we can answer the biggest question. But first, we need to correct a popular myth. Ancient Egypt did not single-handedly invent every part of the modern clock. The division into 12 daytime and 12 nighttime hours has deep Egyptian roots. But our 60-minute hour and 60-second minute are tied to later base 60 astronomical mathematics, especially traditions inherited from Babylonia and developed by later astronomers. So the clock on your wall is not the product of one genius or one civilization. It is a historical collaboration across thousands of years. Egypt contributed the daily architecture, 12 and 12. Other cultures refined equal hours, smaller divisions, mechanical clocks, and eventually atomic seconds. This makes the real Egyptian achievement more interesting, not less. They helped transform natural repetition into an organized language. So did the ancient Egyptians invent time? No. Sunrise happened before Egypt and seasons changed before humans existed. What the Egyptians helped invent was agreement about time. A year could be counted. A season could be named. A date could be written. Daylight and darkness could each be divided into 12 parts. A shadow, a star, or a falling waterline could tell a community when a shared moment had arrived. That agreement made farming easier to coordinate, rituals easier to schedule, records easier to compare, and a kingdom easier to govern. And its echo is still with us. Every time your screen shows 24 hours in a day, you are looking at a pattern with roots reaching back to ancient observers watching the sun and stars above the Nile. They did not stop time. They made it count. But one mystery remains. If Egyptian hours could grow longer or shorter with the seasons, who decided that every modern hour must be exactly equal? That answer required astronomy, empires, railways, and eventually atoms. Subscribe to FactBound, because that is where the story of time goes next.